So just to kind of recap some of the methods of the CPM match service and the differences between the methodologies between CPM scheduling and location-based scheduling, really what we're doing as part of the step-by-step comparison is using the models, if they're available, to quantify the amount of work in each location and to calculate the resource requirements for installation by location. Effectively, quantity and resource loading your schedule from data that you may actually have in Vico Office already, or you may have easily available from other members of the project team. We can then use the tools available in the Flowline interface to analyze the representation of the CPM schedule in Flowline, identify discontinuities of work, unrealistic resource requirements, let's say areas of no work or bottlenecks in the schedule, all of the typical kind of issues that you look to mitigate by optimizing your schedule using the Flowline method. And finally, using the LBMS theory to manage your resources and to provide that optimization and to reduce the overall risk on your project. And so, following these tenets, we provide a schedule file that's aligned with the CPM. We provide an analysis that identifies all the areas that we have found room for optimization, or at least areas that that we may want to just validate, before submitting the baseline, and then using those to target some optimization decisions within your phase milestones or prior to submitting the baseline for approval. Now, once we provide this information for you, we will support the review process by having some optimization workshop time. That's when a Vico representative such as myself or one of my colleagues will come to the job or come to your office, walk you through the CPM alignment, and walk you through the optimization suggestions. That can be done simply internally, or it can be done with the participation of subcontractors. Now we do work with subcontractors often, and if they can provide planned productivity and manpower data, we will definitely include that as part of the CPM alignment process, which is just going to give us even more accurate results as part of the review and analysis. Now, just to run you quickly through some of the process that we would go through as part of the optimization phase after delivering the CPM match. We would want to validate the framework, which would be the location breakdown structure, your task level of detail, and logic. Oftentimes, when we work through the CPM schedule, and given that it's more of a manual translation rather than automated, we're able, you basically have to handle each piece of information as you translate it from the CPM schedule into the flow line, which allows you to scrutinize that information throughout the process. Now, in addition to simply analyzing and providing optimization suggestions in our reports, we also provide kind of a housekeeping list of issues that we may have found during the process. For example, logic, inconsistent logic, let's say, where 9 out of 10 relationships have have one type of logic, let's say finish to start, and then there's one unique location that has, let's say, a start-to-start relationship as opposed to finish to start. We'll document those as well for review, because that could be designed into the schedule just as easily as it could have been a typo. And so from that perspective, we provide kind of a peer review service as well on just the having a fresh set of eyes look at how the data was structured in the CPM schedule as well. And so any of those issues that we've identified we'll revisit as part of the optimization phase, and just to make sure that we've got the logic and the level of detail as tight as possible. Level of detail, of course, referring back to the comment I made earlier about using the model to help identify any pieces of the building that may not have been explicitly accounted for in the CPM schedule. We revisit those as well and see if it makes sense to include those as activities in your schedule. Now, given the nature of the 5D environment in Vico Office, it's a very powerful tool to open and review during this optimization process with the project team in the room. We can use this to support our discussion of location breakdown structure, how to break the work out into work areas for each individual phase, and use that to begin documenting each of the tasks and the unique production data that we're using to validate the calculated durations for each activity by location. This is an example of a Vico sticky. Some of you may have your own company sticky notes. Some of you may use just the standards. Ours are a little bit different in that we're not only asking for your task name and prerequisites, but we're also gathering production data as well. So how is this activity going to be measured? What's the expected number of resources and who? Are they going to be, drywall guys or concrete guys or whoever your individual labor resource or a union shop is going to be, and then the productivity data that will be used to calculate the durations. And so we'll gather all this information and lay it out as part of a pull planning exercise to define and refine, rather, the logic and constraints for each individual schedule phase. Once we have gathered that data, we can input it back into Vico Office. There's a templatized process for this. We can document all the individual subcontractors involved and their anticipated productivity rates and crew sizes, plug that back in, and use that data to optimize the schedule. Now, once we plug that data in, sometimes it has some immediate adverse effects on your schedule, as you might see here. Never fear. That's what the tools of the Flowline schedule are for, to help you re-optimize your plan after inputting what you perceive to be the actual data that's going to be achieved in the field. So once we get those manpower counts and productivity rates applied to the quantities in the schedule, we can adjust our resources as needed to align the production rates from activity to activity. Typically, this is done with the subcontractors in the room, and so you're not simply saying, yeah, that guy can bring 20 guys, or that subcontractor can bring 20 guys for this activity. We're asking them how many guys they can provide, and not only how many they can provide, but what's the optimal number for their crew size. What we're trying to do is utilize the quantity and production data that we have available, apply that to the CPM schedule that's already been defined, and then use it to refine the schedule and to optimize, to leverage the or to use the most efficient installation methods as possible, which of course also reduces the risk and increases the predictability of your schedule. Now, when you are, if you are able to adjust the resource plan for your activities, the goal is to make your activities as parallel as possible in the Flowline view, which means the production rates are in alignment and you have kind of equidistant buffer between the activities in each location, which is a reflection of the reduced gaps and bottlenecks in your schedule. Other typical issues that you may find as part of the optimization process and as a replication of the CPM schedule, which you may be starting from, discontinuities in your activities, in addition to the to the wasted time and the bottlenecks. Sometimes you've got lines that are overlapping within your flow line view. Overlapping lines are an indication of multiple activities active at the same time in the same location. Now, depending on your location size, this may not be a problem, but it may be a problem. And so these are areas we want to highlight and validate with the project team in the room to make sure that we understand whether or not that's too many people in the space for the activities that we intend to have active at that time. Of course, we're looking to balance the resources as much as possible, minimizing the number of peaks and valleys and trying to get more of a bell shape to our resource graph by subcontractor and also overall. It becomes very interesting when you project the resource graph for the entire project, but more importantly by location for all active trades. You can quickly see that area A is suggesting for the next 3 weeks you're going to have 30 guys active. That may not be you may not be able to support that number of men in your location. And so using the resource graph as a tool and your filtering properties as a tool to analyze the original plan and use that to optimize is one of the goals of this exercise and this service. Of course, reducing the starts and stops, which reduces the risk of guys leaving and not coming back. If you choose to hold your resources on the job site, we can factor that into the plan for optimization as well. And in fact, if you cost load your schedule, which would happen naturally by using the Vico Office workflow with a cost loaded database, you can quickly analyze the cost impact of releasing your resources when there's no work or holding your resources when there's no work. The difference being mobilization and demobilization cost versus waiting cost of those guys being in the field. All of this is part of the optimization process. I mentioned before the importance of designing your demobs if you need to use them, and using the flowline interface as a way to, instead of working from an ASAP method all the time, but as a way to design where you're going to have some breaks in work, not only promotes the most continuous work and the best productivity of your activities, but also is a lot easier on your subcontractors who can then plan to reassign their workers to another job for that period of time, and it's much more likely that they're going to be able to return to work with those same guys on the planned start date when they remob to that activity. So ultimately, the goal of the optimization phase of this service is to synchronize production rates and to align the work from activity to activity within your phase milestones. Let me reiterate or kind of urge to the audience that we're not looking in this case to compress or accelerate your schedule with the CPM match service. What we're looking to do is align our flowline schedule first with the CPM dates by location, with the activity dates by location, and secondly within each of the phase milestones for your schedule. Now, after reviewing the analysis and identifying some potential for optimization of those activities, we can then consider some adjustments on those start dates in order to maybe unify crew sizes, reduce resource variance, or to promote continuous workflow. But we're always tracking to those same phase milestone dates. And so the standard process on Vico's side is to target those phase milestones and optimize within the phase to reduce risk from your milestone dates to dates. Ultimately, after going through the optimization process and with the team and evaluating the opportunities we have and maybe implementing some and then not implementing others. We would provide a set of data in all of the different views that we have available from the schedule planner environment, which would be, if you want to print out a Gantt chart, you can do that. If you want to use Flowline, you can do that. If you want to have a list of start dates, you can do that as well. And we would provide a packet of the signed off optimized plan to each of the team members as you would in a 3D coordination exercise. Basically, this is manpower coordination in the field, and provide this as the optimized plan moving forward. Now, we as a case study for this optimization portion of the CPM match, we'll take this medical center example. This was just superstructure only, and I realize that a lot of the data we're covering today is superstructure. That just happens to be what we had some good examples of for this webinar. But you can certainly apply this exercise to any of the scope in your job. In this case, we really consolidated the effort to just steel erection and specifically the slab on deck activities. Now, one of the highlights of this case study was using coordination models that were provided from a design assist subcontractors. We were able to quantify the number of hangers and inserts that we were going to be tracking and installing before the slab on deck from the coordination models, which I had not done before and was very, very interesting. We had discussed it with the subcontractors who were involved in this exercise, and they were not aware of the total quantities of inserts at that point in time either. Generally, they were, kind of setting up that information and designing their layout process with the layout drawings, a couple of weeks before the installation for a particular location. In this case, we were able to use what was already generated in coordination models to extract those quantities and use them for production planning. So we took that information and templatized it and plugged it into our schedule as a product of quantity and manpower. And you could see in this list that we were able to extract a count of inserts. In this case, the plumbing cans that we had for the slab on deck. We were able to extract that count and identify it and plan for it for each location that we would be installing. Now, that became a very powerful tool for optimization because we were able to determine what was the driving activity in each location, and most of the time it was one of the MEP trade inserts for each of the locations of the slab on deck. Now, what you see in your view here is an example of the CPM schedule alignment. Almost every task was discontinuous, and there was a lot of stacking of those activities. Also, you can see that if you can kind of peer through the colored lines, high resource variability indicated by the change in the number of crew sizes from location to location. So after going through the process of replicating the CPM schedule, we then applied our location-based methodologies to the schedule to produce an optimized version, which looks like this. Much more continuous work, unified or uniform crew sizes, and we were still able to achieve the same end date that we would have otherwise in the CPM schedule. Now, let's see how the resource graph compared between these two versions, the CPM match and the draft optimization. The baseline schedule resource graph is the image at the top, and the optimization is the image at the bottom. Now, as you can tell from this comparison, the resource graph on the bottom is much more consistent, has a lower peak resource count, has fewer peaks and valleys for the total resource requirement for this phase, which, practically speaking, means that if you choose to release your workers when they're not needed, results in fewer demobes and remobes. And if you choose to keep your workers when they're not active, is going to result in less waiting time and less waiting cost for holding those guys on the job.